So we started going over the 4-6 part A, the first part, right? And our goal is always to find that K first. Since it took 6 years to double, we cheated and started with 1 and ended with 2 after 6 years, right? Use our y equals y naught e to the kt. Then we transferred that K into our formula. Y of now, or 30 years after y naught, is 100,000. So put the 30 in for time, 100,000 in for the y. And we got our y naught by plugging and chugging, right? So what is our new formula? E to that K T. So there's our new formula that started 30 years ago. Now I've had a few open discussions about this. In fact, this actually shows up in one section of AB calculus, and I had an AB student kind of start arguing with me because he was like, well, can't you start your y naught whenever you want to start it? That is true. I'm gonna show two ways, because the part B says estimate 10 years from when? 10 years from now. How many years would that be from 30 years ago? 40. 10 years. 10 years from now. This was 30 years ago, right? Was what our starting value was. So I had this little discussion, and it took him a minute to talk me into it, because here's what he said. Let's change it. Let's say why not is actually now. Sorry. Let's say why not is actually now. So our new formula would just be y of 10, wouldn't it? If we started out with the 100,000, e to the ln of 2 over 6. Only we need 10, right? So we're going to plug and chug both of these and see how they give us the exact same answer. You plug in this half of the room, plug in this one. The other half of the room, y'all plug in that one. Or you, since you plugged in this one already, right? Yeah. You plug in the other one. See if it gives you the same thing.
Oh, that's a number. Did y'all get like 300,000? Or am I wrong?
Yep.
Yep.
And I just plugged them both in and got exactly the same answer.
So yeah, that makes sense.
I got 100,000. Did you put 30?
Yeah. 100,000 would have been correct for now, right? So again, somebody or somebodies are pregnant in some way, shape, or form. The point 2 means there's a baby growing. Or multiple. All right, part C, sketch a graph. I said no sketches. Makes no difference, doesn't help us in any way, shape, or form, because all exponentials will look like this, won't they? Yeah. It's just that this one is going to start out at 3,125. Oh, or this one would have started out with what? 100,000. All right. Number 6 was worded and just was a little bit different. a little bit wonky. A population of a certain species has a relative growth rate of 1.2% per year. So if we're sticking with our y equals y naught e to the kt, the growth rate of 1.2% means if I start out with 1, how much will I end up after 1 year? 1 point what? It was a 1.2%.
So 0.012.
Yeah, which equals 0.012. So after the 1 year, we would have 1.012. Everybody understand that?
Yes.
Wait, can you say that again?
1.2% means changing to a decimal 0.012, right? So if I start out with 1 and grow 1.2%, I'm going to actually multiply this by 1, aren't I?
I see.
Am I multiplying?
Because if you just multiply, it would just be 0.012. If you multiply by 1, it would be 1.
No, it's 1 plus, yeah. If I start out with 1, plus I grow 1 times 0.012, right? That's what it is. Start out with 1, I grow another 1.2%. There we go. Divide by 1, though, we still get 1.012, correct? How do I solve for the K and L? ln, this one's almost easy. Correct? Now, it tells us population, relative growth rate. It is estimated that the population in 2000 was 12 million. Are we going to start our time at the year 2000? No.
No.
Yeah.
But-
It says, it was estimated that the population in 2000 was 12 million.
Mhm.
I'm going to say that's the starting amount. Now, when I did this problem, I actually did 12 with 6 zeros. Do you want to do 12 with 6 zeros?
No. Should we? Yeah.
Does it get complicated?
Can we just do 12 to the power of 7?
What?
Is that Millie?
Times 10 to the
Times 10 to the
7th
power of 7.
times 1.2 times 10 to the 7th. But let's just leave it. So our formula that we need is 12, 3, 4, 5, 6, e to the ln of 1.012 t. That's our formula. Is that what they asked for in A? Find an equation. Yeah, I know they called it N. Who cares? They have the zeros.
Like a 0.0.
Wow, this feels much easier than 3.
Estimate the fish population in the year 2005. Starting in the year 2000, right?
Mhm.
So we're just going to do y of 5, correct? So we're going to replace the t with 5. I refuse to write it one more time. 1, 2, 3, 4, 5, 6. E to the ln of 1.01. It has to be 1 point because it would be the ln of 0.012 would actually be a negative number. So it would have declined. Part C, this guy's a graph. Heck no. I'm making up Part D. When will the fish population reach 15 million? You don't know how to do it when we ask for that one, when. What are we looking for when we have a when question? What year, which is what in terms of the formula? The time, yeah, the T. So I'm just gonna go 15, 1, 2, 3, 4, 5, 6. And for the Y, right? 3, 4, 5, 6. E to the ln of 1.012. And leave the T and solve for it. This is kind of why I didn't want to leave it as all the zeros. However, if we're dividing those fractions, what happens if we divide the top and the bottom by 1,000,000? Yeah, it's 15 over 12, right? And that could even reduce 5 over 3, 5 over 4, divide by 3. Is that right? You just pulled a J-dog mistake. J-dog mistake. All right. Pulled a J-dog. What do you do now to solve for the T? Natural log 'em. So it's the same process whether we're looking for the K originally or looking for the T. It's the same thought process, right? Power down in front. Natural log of E is 1. Y'all got it solved?
I'm done.
Good. Calculator. $18 point what? 66, or so we'll call it 18.707. Ooh, that's years. So what? Did it say what year? Or when will it? In 18 years, or in 2018 at some point? Correct.
I got it.
After July, or after June.
No, I
Sorry.
How do you do that if there's like 10, if it's counted in tens, but there's 12 months in a year?
What I do is I subtract out the 18 and multiply it by 12 months.
There we go, 18.
It would be August. Or no, yeah, sometime in August. I said it was after halfway through.
Which was correct. When's your birthday, J-Dog?
June.
What's
Yours is
your-
in June? 26.
What's your favorite month?
It's my favorite month. Je ne sais pas. I do
What?
not know.
October's the best month.
My favorite month is either May or December. Because school ends in May and Christmas is in December.
The M months, we have the M months.
The embers are the best months. Embers in the open.
March and May, I hate it.
September,
Okay.
October, November, and December are the best.
Yeah.
April is.
October, the fall's the prettiest, and it's March.
Miss Washington, are we learning new materials today?
I'm a band.
We're gonna add in those like the pH things that have log formulas and the Richter scale or something. So, I mean, literally, it's just plugging into those formulas, and I'm probably not even gonna test on it, because we never use them in
You're what?
calculus.
I saw an ice cream that is cosmic Graphics later.
Okay, guys, everybody understands, at least from this graph, somebody give me what the deer population is in 2003.
20,000.
20.
Yes, 20,000. In 2007,
31,000.
31,000. Because they give you those points, right?
I was only off,
Hey,
they had 48,064. I had 48,050.
So we're gonna call the year 2003, why not?
Really fast.
yeah, like,
It just like teleported onto the page.
it's just,
Okay. So if why not is the 20,000, what is at 2007? Y of what?
4.
I agree. Y of 4 is 31,000, right?
I got 5.
3, 4, 5, 6, 7. Perfect decimal system right here on your fingers. So, bless you. So what we can do is use this information to find the what? The K that we always have to find anyway.
Why don't they just give it to ya?
because then it wouldn't be a math question.
Wow. Yeah, 1 plus 2 is math.
That's like.
It would be a calculator, plug in, chug in, who cares? You gotta
I
have,
care.
Me?
you gotta have some work to do.
Well,
What was the year? 4.
Yeah.
Divide both sides by
20,000.
20,000. Cancel out all of them zeros. 31 over 20 equals e to the 4 times k, right?
it's 1.5 almost.
So 4k equals ln of 31 over 20. K equals ln of 31 over 20 divided by 4. Wait, are you doing decimals for this?
It's just that my brain decimals better than fractions, but I can't fraction.
You can verbalize math too. I like it.
Wait, what? Oh, okay, I did it right.
It's really light.
No, it's a really small decimal. 0.109.
I was talking about 31 over 20, or 31 over
31
20.
over 20.
That's
Oh,
one.
1.5. I got you. Yeah. All right. So, part A says, oh, what was the deer population in 2003? Well, done right there.
Yeah,
Part B is find a function that models the deer population t years after. Well, here's where we go. 20,000 is our initial. E to the k we just figured out. I keep looking at that and thinking it says 30.
Say how you have to write.
Yeah, it's a little, hey, but I didn't assign that many. What is the projected deer population in 2011? What time would that be? 2003. 4, 5, 6, 7, 8, 9, 10, 11, 8.
your camera is delayed by like a second. It's really funny seeing it jumps in the screen.
Yeah, I was recording this morning and I was on a Zoom call for Virginia Western to observe me, and the delay was like just
That's all.
ridiculous. It was bad.
You know what's like, I'm fine if it's like a minute.
Pardon?
I did it instead of 20,000, I did 39,000, instead of 8, I used 4.
Did it work? I think.
No, it was off by 14.
What did you get?
I got that.
Oh, I did not get that.
Yeah, I got that, but in the back of the book it's 64 instead of 50. Why did you multiply it by 6? I got.
What's 4 into 8? 2?
Oh, I didn't get
There's no about, it's exactly.
The back of the book literally says about 48,000.
Oh, funny.
I thought it said
They
48.
probably wanted
It's
you to look at the graph.
Do what?
They like simplify.
Oh, well, or they use a decimal and round it. Yeah, I'm way not for that. Because if you round it too small or too big or whatever, round it too much, your final answer can be way off. So that's why I know I do not do rounding.
I'm still trying to
leave
type
it.
this stupid thing in the calculator.
And what year? This is the part. When will it reach? What year? In what year will it reach 100,000, dear?
And now we're finding T.
So now we're finding T. Where do we put the 100,000 in? The Y.
How comes? What's my guess? My guess is 20.
Mine's 82.
My guess is
17.
My guess is
2017?
The last one was 18.
I'm confused how you figured out where to put the 100,000.
Because the Y.
This-
is the-
You have to
This
equal
is
100,000.
the amount at the end, right? After
And if we already
T
have it now.
years.
Then how? I thought you
So
said
that
100,000
has to be,
was the initial,
why not as the initial?
but the 100,000.
This Y of T is the amount after T years. Maybe we should throw down not a plain Y, but Y of T. It's a function of time. K is a specific constant for this particular population.
So essentially,
K equals
it's just
constant.
what you have to
That's why I
equal
was
to.
confused how you were able to put 100,000 and then Y of 8 in the same spot. Like, different questions, obviously.
Y of
but
8 is the amount after
I just
8
didn't
years.
envision a T there, so I didn't know how you could get rid of the Y. but
So now you're
also
trying to
how
find
you
the T in front of the 1,000. Or beside.
That reduces to 5, right?
Yeah. Nine equals this giant number.
How do we get those T, how do we solve for the T? Hey, Sarah, this is the part that you have to get that from the last class. If we're solving for an exponent, what do?
We
Natural log, both sides. And especially with ease, you could do a common log, but with ease, we definitely don't want a
And then
base
just
10.
equals 1.
Yes. Natural log of E is just 1. We rarely write it. Now, T is being multiplied by a fraction. If I'm getting it kind of calculator ready, I'm flipping the fraction and multiplying, right?
So then it's 4 ln 5
Bless you.
ln 31 over 20. Sorry?
So this would be the exact value of T.
Wait, why do you multiply to the
I'm multiplying by the reciprocal, which is the same as dividing.
Oh,
You get the same answer.
so the T is left by itself and you put this whole thing in a calculator?
Yep.
Okay, let's see if it doesn't take me 2 minutes.
Let's go team. You got this. Why? I never click cosine. What are you talking about? We're not doing trig anymore, please.
So 2003. Oh, it would be 2017. Like
Good job.
after July or whatever, right?
Is it
Or
45.6?
in July, maybe.
14.
0.6895.
Wait, I didn't put LN next to it.
That'll do it.
Easy places to make J-Dog mistakes.
He makes J-Dog mistakes every day.
Is it 14?
Yes.
6, 8, 9.
Well, technically,
So I
1.6.
It was apparently I read something else in the backwards that I did not read.
Technically, it's 0.6.
All right.
An advisory.
Number 19 is radioactive strontium.
Strontium, yay. I love strontium.
Yeah.
I thought that was 17.
No,
That's
that was
19.
11.
17.
Dog mistakes. Gotta love strontium.
Okay.
Pray for spring.
Relative growth rate was at 2% per year. Guys, number 17 is not very much. Number 17, I was reading 16. Another J-Dog mistake. I love myself.
Self-love.
Self-love. Pat myself on the back. All right, this one is the one where I said, I might not have said it, but part A is out. I don't use that junk with the 1/2 thing. Right. Or 2 to the negative. No. I do part B, although I don't use the negative, because my one formula for this time is y of t equals what?
Yoked. No.
Yoked.
Yoked. I got a thing right.
So, the half-life of radium-226 is
So funny.
1,600 years. What does half-life mean, people?
Half-life.
The time it takes for half of the product to go away.
Yes. That.
Yes.
That's what I meant, obviously.
It's decay.
All right. Suppose we have a 22, is it milligrams or grams? Milligram sample. Part B is where we're starting. We're definitely not doing A. So, here's the deal though. To get our K for half-lives, just like we did for doubling, we cheat. We start out with 1 and end with how much?
1.
A half. E to the K after 1,600 years, that's our time. It takes for half to go away, right? ln both sides, 1,600 K equals what? ln of a half. And so K equals what?
Ln of a half over 1/1600.
There we go. If you want to call it ln of 0.5, since you're a decimaler, you're welcome.
Do you put that anywhere? It just what? Oh, that's a number.
Correct.
That's a number.
Yeah.
That's
Is it a teeny tiny number? Way. Negative. A negative teeny tiny number. All right. Yeah, because it takes a long time for it
But
to
like,
decay,
but-
right?
But it has an
So
E.
everybody understands.
Did I do it wrong?
No, mine is an E.
What did you plug in?
ln 1/2 divided by 16.
Was it negative 0.00 something?
3321698 E minus 4.
E minus 4 means times 10 to the negative 4. That's what capital E.
Yeah, real small number.
Yeah. So that's 0.0000000 something something something, right? All right. So this is why. This is precisely why I don't use a decimal. Because if you round this, I had to combat this pre-calc teacher that had my kids before me in calculus,
Oh,
and they
they
kept
were-
like rounding to like 3 decimals here. Well, if you want your answer right to 3 decimals, you cannot round an exponent to 3. Like you got to go 5 or 6
Yeah,
or
so
7.
that's why you just don't plug in the K.
I just don't plug it in. I definitely.
Smart.
Y'all got a problem?
I don't know what's wrong with her. It's just-
So part B was actually find the function. How much will remain after 4,000 years? What are we finding?
or is that
Yeah,
1.5?
y of 4,000. Plug and chug, right? Replace the t with 4,000. Anybody got it?
3.889.
What? 3.889 milligrams. makes sense, because half of it, it's gone down to 11 milligrams after 1,600 years, right? Half of that would be 5.5 after 3,200 years. So 4,000 is going to be certainly less than 5.5. D, how long will it take? Guys, after we've done all of our other finding T's, how long will it take to go down to 18 milligrams? I want you all to do that one. Where does the 18 go? We've just done 2 others.
Goes in the
Why
thing.
not?
It goes into y of t,
Yes.
and we're finding the t. Where does the rest go? That nonsense. Leave the t. Now, can we solve it? You did it just like this?
Maybe you plugged it in wrong. Or did you?
Is that 9 over 11? I mean, not that you have to reduce it to 9 over 11.
Yeah, I reduced it to 9 over 11.
E to the ln 1/2 over 1600 t. Lnum, ln, ln, ln,
And then when you cross or not, multiply by the reciprocal.
multiply by the reciprocal. Look at you mathing.
Yo, verberizing.
You're verberizing math terms.
I like how you verberized a verb.
Yes.
It's like the first word you should verberize.
Let's go verbing.
Go verbing. That sounds like something that would be cited.
Like super wide.
No, I was thinking like the 60s. Like that's just weird slang.
463.
Thank you.
0.210.
That was a funny joke. You're pretty funny, but looks on there.
463?
Yeah, that's
You
not what
okay?
I got the first time.
Yes, because I got it right.
Good for you. You're so
After
funny.
463 years, it would go down to 18 milligrams.
Yeah, I don't know what I got. I got negative 1,886.
So guys, now that we've done these, can you do 19?
Where's 19? It's still in your book.
Radioactive strontium half-life is 28 years. Strontium 90. How long will it take a 50 milligram sample to decay to 32? That just jumps straight to D, doesn't it?
Right?
Straight to D. Gotta jump straight to D. Half-life of strontium 90. Strontium 90 has a half-life of 28 years.
Right.
How long will it take 50 milligrams to decay to 32 milligrams? So
We're
what?
finding T.
We're finding T. But before we can find that T, we gotta find the K,
Which is this.
which is from the half-life.
So we're going 1 to 1/2?
1 to a half. We're cheating. E to the K times what?
Times 28.
That's
28 years.
And then your ln.
ln 28K equals ln a half. What's our K equal?
L in 1/2 over 28.
You got it. I'm gonna go y of t. Does that help you at all? Maybe not.
Now do we do? Wait.
So our formula y of t is 50 the starting amount, right? Why not?
Which, and that's 32.
And this is y of t that we don't know the t, right? Everybody with me? I wish I'd made y'all do it.
Come from?
It asks how long it's gonna take a 50 milligram sample to reduce to 32. It gave us that.
Oh, radioactivity, fun.
I'm gonna make y'all do this part. Y'all do it. Everybody writing.
I got you.
Nobody
Not right.
not writing. Nobody slacking. Unless you had already done it,
It's 30.
in which case you're not slacking. Did you already get it, Tyra?
I don't feel like, what's it called?
Yes. I ain't telling you,
And then
girl.
go in- Oh, sorry.
I mean, you can math enter it if you really want to.
In your, if you want. Okay.
I think it's just 2. I think it's just 16 over 25.
Yeah.
Wait.
Yo, perfect squares, let's go.
I want y'all to do it yourself, so I'm not, I do tend to like try to go too fast myself.
Really? I tend to go too slow, so.
Oh man, I got rid of a number that.
Really?
What are we trying to find here?
The T.
Messed up. I got rid of the T, that's the problem.
Just move your camera. Like, just,
I don't want you to see my answer.
so move the camera. That's what I'm saying.
Can I do it the way I want to?
Hold on, let me see if I got the right answer.
It doesn't matter if I divide it, and it doesn't matter if I multiply by the reciprocal. It's the same.
Multiplying by the reciprocal is the same as dividing if you're on a calculator.
Either way, it won't, I keep getting it wrong.
You do?
I don't know what I'm doing wrong. For both, 17D and 19. I don't know what I'm doing.
Okay, wait.
Are you forgetting to end parentheses?
I got negative 2.8.
I got 18.028.
Where did you get the 16 over? Oh, I didn't simplify it, but that shouldn't matter, right?
No, 32 over 50 works.
Alrighty, we're mathing, we're mathing.
Yay!
We're mathing.
Let me see your calculator. Can I see your calculator?
We're mathing. Oh Lord, we're mathing. Oh Lord, you Lord.
Oh, wait. Wait, that's not. I got that answer, but I not put that in.
this.
Alright.
in my calculator.
Should just multiply them together.
Okay.
What was the,
Wait, where'd you get 32? Oh, 32 over 50?
I got the right answer.
Oh, no, the natural log is of the 32 over 50.
Well, I'm Jewish, so it's not.
Oh, so it should be.
The 25 is on the bottom.
Of ln.
Yeah, so if you're doing it your way, it needs to be over
And
1.
then times. There we go.
ln of
ln
30 over 50.
I figured it
And then
out.
in the parentheses.
32 over 50.
And you just touched it.
My bad.
Was yours like her issue? Where-
18.027.
Yep, I got it.
All right.
Wow.
And the answer would be 18.028 what? Years. Good.
Yars.
Yay.
Damn.
Wise.
I'm wondering
All right.
what happened if like a foreign student just sat in on our class, like they didn't understand English.
Oh, that would be so bad. I would feel really,
I don't
I would
understand.
try
Like,
to speak a little bit more eloquently. That was the exact word I was going to use.
Spell eloquent.
Eloquently. All right.
Miss Washington, spell eloquent.
ELOQUENT, I believe.
Good job. I have a